So hello everyone. Today we are going to solve our next question on LeetCode, and that is H index. So it is saying that we have given an array of integer citations, where citations of I is the number of citations a researcher received for their ith paper. So let's say you are a researcher, you are a researcher, and you have published multiple research papers there. So these are the research papers you have published. Now there are multiple people or multiple researchers who are taking a reference from your research paper. So these are the people who are taking reference from your research paper. That is known as citation. So citation is nothing but these references from your research paper. Now we have to return the researcher's H index. And if you will see that what is H index, then H index is defined as the maximum value of H such that the given researcher has published at least H papers that have been cited at least H time. So let's say your H index is 2. So what does that mean? That simply means that there should be at least 2 paper which will be cited for at least 2 times. So now let's understand it with the help of this example. So this is 3, 0, 6, 1, and 5. Now, can 1 be our H index? Yes, 1 can be our H index. So for 1 to be an H index, there must be at least 1 paper which should be cited for 1 time. So here we can see that these are the papers, this 1, 3, and 6, 5. So there are 4 papers which are cited for 1 time, at least 1 time. So 1 could be our H index, but we will not consider it as our H index because we have to find the maximum value of H. So can 2 be our H index? So here are 3 papers, that is 3, 6, and 5, which are cited for at least 2 times. So this can be our H index, but let's move further and see with 3. Can 3 be our H index? So there are 3 papers, that is 3, 5, and 6. So there are 3 papers which are cited for at least 3 times. So 3 could be our H index. Now let's check it with 4. Can 4 be our H index? So now there are only 2 papers here, that is 5 and 6. So there are only 2 papers that are cited for 4 times or more than 4 times. But to make this 4 as H index, there must be 4 papers that should be cited for at least 4 times. So this could not be our H index. So the maximum value of H index is 3. And as here you can see, this is the output. So now let's try to solve this. Now here we are taking this example to solve this. So what we will do here, first we will take an array. So here we will take an array. And the size of this array should be 1 greater than this citations array. So this is a citations array. And the size of this array should be 1 greater than this citations array. So its size is equal to 6. So its size should be 7. So if you will see as per the index, then its size is equal to 7. Now, why we are taking this size, this array, which is one size greater than this citations array? So here, as we can see that there are 6 elements in this array. So the maximum H index value that we can have in this case is equal to 6. Why? Let's see. Now, let's say instead of this 3, 0, 6, and 8 and 5, let's say if we have all the values as 7. Now we have, let's say, all the values as 7. Now, if we will see that there are 6 papers. So these are the 6 papers which are cited for at least 6 times or greater than 6 times. So these papers are cited for 7 times. So here we can see, we can say that there are 6 papers which are cited for at least 6 times. So this is what the definition of H index. So 6 can be our H index in that case. So to define this 6 as an H index, basically to define values from 0 to 6, as index starts from 0. So we have to take 7 size, because 7 size can define this array from 0 to 6. So that's why we are taking this array one size greater than this citations array. Now what we have to do is, now let's loop through this array, loop through this citations array, and try to traverse the whole array. And as per the value is inside this citations array, keep this value in this array. So what we will do, first we will come here at this place, and as we see that the value here is 3. So what we will do, initially all the element inside this array is equal to 0, but now as we have got this value 3, so we will simply come here and put this as 1. Now again we will come here at this place, here it is 0, so we will come to 0th index and put 1 here. After that we will come here at this place, now it is 6, so we will go to the 6th index and we will put it as 1. Now again we will go here at this place. Now the value is 7, that is greater than 6, that is greater than the length of this array. So in that case what we will do, we will simply put it at the last place. If the value is greater than 6 and the size of this citations array is 6, then what we will do, we will simply take it and put at the last. So here it will be 2. Now again we will move forward. Now here we are getting 8, so we will take it and put it here at this place as it is greater than 6. Now we will come here, and after that this is 5, so what we will do, we will come to 5th index and make it as 1. So let's create a different array to visualize this. Its value is 1, 0, 0, 1, 0, 1, and 3. So this is our final array. Now let me write the index for all of these. It is 0, 1, 2, 3, 4, 5, 6. Okay. Now what we will do, we will start traversing from the back. Why we are traversing from the back? Because it is asking for the maximum value of h, such that at least h paper should be cited for h times. So to get this maximum value, we will start from this last index, because here this 6 is representing that what is the greater element that is cited for h times. So what we will do, we will start from here and we will see that uh, here we will take a count variable. Initially, the value of this count is equal to 0. And as we come at this last index, so what we will do, we will simply add this value to this count variable. So it will be equal to 3. Now we will check one condition, that whether this count is greater than equal to I. If this count is greater than equal to I, then in that case, we will simply return I. Why we are doing this? Because let's say, if instead of this 3, it would be 6. If instead of this it would be 6, then it represents that there are at least 6 papers, 6 research papers that are cited for 6 times. So in that case we will simply uh, return this as a result. But as it is 3, which is not equal to 6, so what we will do, we will simply move backward. So here we will come here at this place. Now after that we will again check that first we will add this 1 into our count variable, so it will be equal to 4. Now we will check that whether this count is greater than equal to the index. This count is not greater than equal to index, we will simply decrease the pointer. Now we will add this 0 to the count, so it is not going to temper the result. Now again we will check whether this count is greater than equal to I. So this count 4 is greater than equal to index 4. Yes, this condition is true. So from here, we will simply return this result. So this 4 is our final result. Why? And as if we will see in this array, then there are at least 4 elements. So there are at least four elements that are 5, 6, 7, 8 that are cited for at least 4 times. So this 4 will be our final result. Now, if we will see time complexity for this, then in that case, we are simply traversing it 2 times. First time to populate this array. So it is O of n. And next time to traverse from back. So it is also equal to O of n, which is approximately equal to O of n, that is your linear time complexity. And if you will see space complexity, then here we are taking another array. So for this, the time space complexity is also O of n. So this is what it is. Now let's try to write the pseudocode for this. Now what we will do here, as we have to implement this h index function, which is taking this side distance as parameter. So what we will do, here we will write pseudocode for this. Now this is the function we have to implement. Now let's take one array which is equal to, let's say n is the length of the side distance array, so it is equal to n plus 1 size. After that, what we will do, we will simply start traverse into this array from starting to end. And for int c in citations, and we will populate this array. So here, if we will check that if this c is greater than 10, in that case, what we will do, we will if this c, that is the element which is greater than the size of the array, in that case, what we will do, we will simply keep it at last. So what we will do, in that case, we will do array of n plus plus. We will increase the last counter. Else what we will do, else we will do array of c plus plus. After that, what we will do, we will take a counter variable and start traversing from back. So for int I equal to n, I greater than equal to 0, I minus minus, and we will do count equal to count plus array of I. As when we will come here, we will simply take this variable and add it to our count variable. So here we are doing the same. And at any point of time, if this count is greater than equal to the index, that simply means we have got our result and we will return this index. So this will be our final result. Now let's try to code this. So first we will take an array. Before that, let's extract the size of this array into a variable. And we will take this array of size n plus 1. After that, we will loop through this array and we will check that whether c is greater than n. If c is greater than n, in that case, we will make this n incremented. Else, what we will do, we will simply increase the particular index. After that, we will come out of the loop and take a counter variable and let it start traversing from last index. For int I equal to n, I greater than equal to 0, I minus minus, and here we will check that whether this, what we will do first, we have to add this variable into this count variable. After that, we will check that at any point of time, if this count is greater than equal to I, that means here we are getting our result, and simply from here we will return this I. Now as its return type is int, so here we have to return an integer. So here we will return 0, although code will not come at this place, but as the return type is integer, so we are returning 0 here. Now let's try to run this. And it is accepted, submitted. and accept it. So that's all for today. Thank you.